The proof of the beginning of time, according to Hawking and Penrose. Stephen Hawking wrote in his book The Universe in a Nutshell that he and Roger Penrose were able to prove that, within the mathematical model of general relativity, time itself must have a beginning at what is known as the Big Bang. Similar arguments also showed that time would have an end when stars or galaxies collapse under their own gravity to form black holes. In this way, they avoided Kant's contradiction of pure reason by rejecting the hidden assumption that time has an independent meaning separate from the universe. Their paper demonstrating that time had a beginning won second prize in a competition organized by the Gravity Research Foundation in 1967, and Hawking and Penrose shared the $300 prize. Hawking later remarked that he doubted any of the other winning papers from that year had left much lasting value. Their work received mixed reactions. It disturbed many physicists, while it pleased religious readers who believed in an act of creation, as it seemed to provide scientific support for such an idea. Hawking and Penrose argued that time itself did not exist before the Big Bang, meaning there is no meaningful way to speak about before the universe began. The concept of time, as we understand it, started together with the universe itself. Everything in existence, from the smallest atoms to the largest galaxies, began evolving from that first moment. We can imagine the early universe as an extremely tiny and unimaginably dense point, filled with enormous energy and heat. At that stage, the ordinary laws of physics no longer behaved in the familiar way, because everything existed in an infinitely compressed state. Then the Big Bang occurred, not as an explosion in empty space but as a rapid expansion of space itself. As the universe expanded, stars and galaxies gradually formed over immense periods of time. What makes this discovery remarkable is that it connects modern science with broader philosophical questions about the origin of existence. Hawking and Penrose showed that time itself began with the universe, which means there could be no earlier moments in time before the Big Bang. Every moment in the universe is influenced by matter and energy, because matter and energy curve spacetime, the unified structure of space and time, and this curvature affects how time passes. This opens profound questions about why the universe exists, and why it has the structure we observe today. Their work was not merely a speculative theory, it gained major recognition within the scientific community, and attracted the attention of many people seeking a scientific understanding of the universe's beginning. In this sense, science becomes a window into the earliest moments of existence, turning questions once considered purely philosophical or religious into subjects explored through mathematical equations and observational evidence rather than abstract assumptions alone. We may picture the beginning of the universe as a state smaller than anything we can imagine, yet containing all the matter and energy that exists today. At that moment, neither space nor time existed in their present form, and everything was compressed into an unimaginable density. Then the Big Bang initiated the expansion of space itself, carrying all matter and energy along with it. Over time, the universe cooled, the first atoms formed, then stars and galaxies emerged, eventually producing the cosmic structures we observe today. This picture reveals that the universe is neither static nor eternal in the classical sense, but rather has a definite beginning that science attempts to study and describe with increasing precision. It also demonstrates how deeply matter, energy, space, and time are interconnected. Every new moment in the universe depends on what came before it, and every expansion of space forms part of the universe's ongoing history. In this way, science serves not only as a tool for describing the cosmos as it is now, but also as a means of understanding the story of the universe from its very beginning.